This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A roof opening does not make the roof load disappear. It changes the route. That is the central idea I want you to carry through every skylight, chimney, and framed roof penetration. The rafters that used to run continuously toward bearing are interrupted. Their load still has to go somewhere, so the opening needs a deliberate path around the void and back to reliable bearing. Imagine a contractor who lays out a large skylight, cuts first, and plans the framing afterward. The cut ends lose their original support, the roof is open to weather, and the crew is pushed toward a rushed repair. The better supervisory decision is to confirm the approved detail, member sizes, connections, weather plan, and opening protection before the first structural member is cut. I remember the load path with one plain sentence. Cut load goes to the header load goes to the trimmer, and trimmer load goes to bearing. When I inspect an opening, I follow that route. If any step is missing, improvised, or unsupported, the opening is not ready to be concealed. The cut short rafters or ceiling joists that end at the opening are commonly called tail rafters or tail joists. They are not scraps and they are not unloaded members. They still carry the portion of roof or ceiling assigned to them, but instead of reaching their former support, they terminate at a header. The header runs across the cut ends. It collects the loads from those tail members and transfers the loads sideways. The trimmers run parallel to the original rafters along the sides of the opening. They receive the header reactions while continuing to carry their own roof load. That is why a trimmer may need more capacity than the ordinary member beside it. I put the framing rolls into a simple reference table. Read it in load path order. Tail rafter, then header, then trimmer, then bearing. The table is not a substitute for approved plans, but it gives me a fast field check. I can ask whether every cut member lands on a header, whether every header lands on a trimmer, and whether each trimmer has a real path to bearing. A crew can make an opening look square without making it structurally complete. A neat rectangle is geometry. A complete load path is structure. I inspect the transfer of force, not just the shape. For conventional prescriptive framing, the California Residential Code provides specific thresholds for headers, trimmers, connections, and long-tail joists. For an engineered opening, a manufactured truss, an unusual roof load, or any condition outside the approved prescriptive detail, I stop treating the table as a design recipe. I follow the approved plans, manufacturer instructions, and design review required for that project. The first threshold is 4 feet. When a header span does not exceed 4 feet, the code permits a single header member of the same size as the surrounding ceiling joist or rafter. A single trimmer may carry that single header only when the header is located within 3 feet of the trimmer's bearing point. That 3-foot condition is easy to overlook. A short header does not automatically make a single trimmer acceptable anywhere along the roof. The location of the header reaction matters. The prescriptive permission depends on being close to bearing. Once the header span exceeds 4 feet, both the header and the trimmer joists must be doubled and must have enough cross-section to support the load. I keep the rule clean in my head. More than 4 means double the header and double the trimmer. The next threshold is 6 feet. When the header span exceeds 6 feet, approved framing hangers are required at the header to trimmer connections. The 6-foot rule is about the connection, not just the number of plies. A double member with an unapproved connection is still an incomplete detail. The last threshold in this group is 12 feet. Tail joists longer than 12 feet need support at the header by framing anchors or by ledger strips measuring at least 2 inches by 2 inches. This is a different measurement from the header span. 4 feet and 6 feet refer to the header. 12 feet refers to the length of the tail joist running into that header. The threshold table puts those decisions side by side. 4 feet controls when prescriptive doubling begins. 6 feet controls when approved header to trimmer hangers become mandatory. 12 feet controls added support for long tail joists. The separate 3-foot rule controls when a single trimmer may carry a single header near bearing. I attach each threshold to a question. Is the header more than 4 feet? More than 6 feet? Is the tail joist more than 12 feet? Is the single header within 3 feet of bearing? That sequence keeps the measurements from trading places in my memory. The published CSLB study outline identifies roof framing as testable material. The important skill is knowing which dimension controls which decision. A 5-foot header and a 13-foot tail rafter create separate requirements. Doubling for the header span and added support for the long tail rafter. Consider a hypothetical retrofit with a header spanning 5 feet. Before cutting, I verify the approved detail and temporary support. Because the header exceeds 4 feet, I expect doubled headers and double trimmers under the prescriptive rule. Because it does not exceed 6 feet, the specific hanger trigger based only on header span has not been crossed. Approved plans may still require hangers, and those plans govern. Now suppose one of the tail rafters runs 13 feet from the header to its other support. That length crosses the 12-foot threshold. I verify a framing anchor or a ledger strip at least 2 inches by 2 inches at the header. I do not confuse that support with the header to trimmer connection. They solve different connection conditions. The sequence matters. I want temporary support, layout, opening protection, weather protection, hardware, and lumber coordinated before the cut. I also want required inspection or design review scheduled before the work is concealed. A manufactured truss is a stop sign for improvisation. I do not authorize a cut because an opening appears to fit between webs. I use the approved truss or engineering detail. The field decision is to recognize the design boundary before structure, schedule, or inspection is put at risk. A skylight opening adds another system to the structural frame: water management. The frame can be perfectly square and still fail as a roof opening if the curb, flashing, underlayment, and product installation do not work together. For a skylight on a roof with a slope of less than 3 units vertical to 12 units horizontal, the prescriptive rule calls for a curb extending at least 4 inches above the plane of the roof. The raised curb places the skylight above the primary drainage plane. I still follow the approved product instructions and project details because the curb, flashing kit, roofing material, and roof assembly must be compatible. I grouped the key skylight and chimney conditions into one reference table. The low-slope skylight row ties a roof slope flatter than 3 to 12 to a curb at least 4 inches above the roof plane. The chimney rows separate combustible clearances from the water diversion rule. The Wildland-Urban Interface row reminds me that the glazing specification changes in designated areas. A common supervision mistake is treating flashing as something that begins after framing. It begins with dimensions and sequence. The rough opening must match the approved unit. The curb must reach the required height, and underlayment and flashing must follow the approved order. Extra sealant does not reliably repair bad geometry. I think of sealant as support, not a substitute for drainage. Water should be directed around the opening by the roof assembly. I coordinate the framer, roofer, and skylight installer before concealment, because each trade controls part of the same water path. Masonry chimneys require 2 different checks that are easy to mix together: combustible clearance and uphill water diversion. For an interior masonry chimney, combustible framing needs a minimum airspace of 2 inches at the front and sides and 4 inches at the back face. For a masonry chimney located entirely outside the exterior walls, the minimum clearance to combustibles is 1 inch. I keep those conditions separate. Interior is not one uniform number because the back face has the larger clearance. Exterior is a different condition with a 1 inch minimum. The practical effect is straightforward. I do not let headers, trimmers, blocking, roof sheathing, or finish framing close that required airspace. A piece of wood that barely touches masonry is not a harmless fit-up. It defeats the clearance condition. I inspect the space before the area becomes difficult to see. The second chimney check is the cricket, or saddle. A cricket is required on the ridge side of a chimney or penetration that is more than 30 inches wide when measured perpendicular to the roof slope. That measurement direction matters. I measure the width that blocks water moving down the roof, not whichever dimension is easiest to reach. The cricket redirects drainage around the obstruction. Without it, water and debris can collect at the uphill face and stress the flashing area. I do not claim that every missing cricket guarantees a leak, but it removes a required water diversion feature and can lead to pooling and rework. For a chimney exactly 30 inches wide, the wording more than 30 inches has not been crossed. For a chimney 31 inches wide in the controlling direction, it has. That is the kind of threshold language I read carefully in plans and code requirements. In a designated Wildland-Urban Interface area, exterior skylight glazing must be an insulating glass unit with at least one tempered pane. For an operable skylight, the research also identifies corrosion-resistant metal mesh with openings no larger than 1/8 of an inch. I do not treat that as a generic upgrade for every project, and I do not assume a standard acrylic dome is acceptable. I verify the location, approved product, listing, and applicable Chapter 7A details before installation. Energy requirements add another approval layer. Exact thermal values depend on climate zone and project scope, so I verify the specified U factor and solar heat gain coefficient against the approved energy documents and product data. Structural framing, fire clearance, drainage, wildfire requirements, energy compliance, and manufacturer instructions are separate checks. A skylight can satisfy one and fail another. I keep the product data and approved documents traceable for the crew and inspector. The moment a roof opening exists, it is also a fall hazard. California Occupational Safety and Health Administration allows a temporary roof or skylight opening to be protected by standard railings and toe boards, or by a securely fastened structural cover. A cover must support the greater of 400 pounds or twice the weight of the employees, equipment, and materials imposed on any 1 square foot. Greater of means I calculate both conditions and use the larger one. A light-looking task does not reduce the fixed 400-pound floor, and a heavy concentrated load can push the required capacity above that amount. The safety table separates cover requirements from task-based fall protection. For the cover, I check capacity, fastening, and marking. For the worker, I check the actual task and height. Those are related protections, but one does not replace the other. The cover marking must read exactly, "Opening, do not remove." The letters must be at least 1 inch high, and the sign must be pressure sensitized, painted, or stenciled. Chalk or keel marking is not acceptable. I also secure the cover against accidental displacement. A properly worded loose cover is still a loose cover. Imagine a wet morning when a worker sees a sheet of plywood near the opening. A vague chalk mark can disappear or look like a material note. A secured cover with the required durable wording identifies the void and tells the worker not to remove the protection. I verify the cover after other trades work nearby and before the crew leaves. Opening protection is a live condition that can change during the day. Residential framing fall protection uses different height triggers for different tasks. When employees are walking or working on top plates, joists, rafters, and trusses, the trigger identified in the research is 15 feet. When the task changes to installing starter board, roof sheathing, fascia board, or working outside the gable end truss, the trigger is 6 feet. The central supervision point is task before height. I first identify what the worker is doing, then I apply the corresponding trigger. A blanket statement that residential framing always uses 15 feet is wrong, because roof decking and related tasks use the lower 6-foot trigger. Suppose a crew is 12 feet above the level below. A worker first performs framing work on joists under the 15-foot category. Later, the same crew begins roof sheathing at the same elevation. The height did not change, but the task did, so the applicable trigger changes. I coordinate protection before that transition. A cover over the skylight opening does not cancel fall protection requirements for surrounding work. A worker using fall protection does not allow the cover to be omitted. I treat them as separate protective layers. Inspection. Ready work starts before framing. I confirm the approved opening size, member sizes, spans, bearing, hardware, and engineered notes. I verify that the product and rough opening agree, then coordinate the curb, flashing, cricket, clearances, and safety protection with the trade sequence. I measure the controlling dimensions instead of estimating. Header span controls the 4-foot and 6-foot decisions. Tail joist length controls the 12-foot support decision. Distance to bearing controls the 3-foot permission. Chimney width perpendicular to slope controls the cricket rule. Roof slope controls the curb condition. Before concealment, I follow 3 paths. First, the load path from tail member to header, trimmer, and bearing. Second, the water path, through curb or cricket and approved flashing. Third, the safety condition, through guarding or cover, secure fastening, marking, and task-based fall protection. A missed condition often appears only after roofing, drywall, or finish work hides the area. The result can be removal, redesign, inspection delay, damaged weatherproofing, and trade disputes. A disciplined pre-cover check prevents that chain of rework. If field conditions force a change, I do not let an oral shortcut become the new structural detail. I route the change through the approved design and inspection process required for the project. I want to leave you with one field sequence. Before cutting, confirm approval, layout, temporary support, weather planning, and opening protection. During framing, trace tail members to headers, headers to trimmers, and trimmers to bearing. Remember, more than 4 feet means doubled headers and trimmers. More than 6 means approved header to trimmer hangers. And more than 12 means added support for the long-tail joist. A single header on a single trimmer also carries the 3-foot bearing condition. For the roof systems, check the low-slope skylight curb, chimney clearances, the ridge side cricket above the 30-inch threshold, and Wildland-Urban Interface glazing when applicable. For safety, protect the opening with compliant railings or a secure structural cover. Use the exact durable warning, and choose the fall protection trigger from the task. This is a testable concept based on the CSLB study guide, because roof framing sits within the published General B outline. I am not predicting a particular question. I am giving you a field supervision framework that helps the numbers stay attached to real decisions. There is an audio practice quiz for this specific episode on framing around skylights, chimneys, and roof openings. It is audio-based. I read the questions aloud and you answer by tapping, which is built for the way you may be studying while driving, working, or moving through the day. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. I read those questions because they show me where a rule needs a clearer explanation. Subscribe so I can help you stay on track through every episode until you get your license. I know this process asks a lot from someone already carrying real job responsibility, and I am here to make each study session count